Hi everyone, my name is Cainã Figueiredo and I'm going to present our work entitled Patch or Exploit NVD Assisted Classification of Vulnerability Related GitHub Pages. So in this work we focus on two important entities from the context of cybersecurity, namely patch and exploit, and we particularly focus on these two entities because they directly impact the risk of vulnerabilities. So our interest here is to classify vulnerability-related GitHub pages according to these two entities previously mentioned. And the reason why we choose to analyze GitHub is that it has become an important source of cybersecurity information. And to collect data about the classes for those pages, we rely on National Vulnerability Database, also known as NVD. So in particular, NVD is one of the most prominent vulnerability databases, and it has tagged many hyperlinks related to its vulnerabilities over the years. This is illustrated in this slide. So here you can see a plot where the x-axis represents the time in semesters, and the y-axis reports the number of hyperlinks. And each color here is associated with a different tag assigned by NVD, and it can be observed that the number of tagged hyperlinks is increasing over the time. And here we are interested only in the tags patch and exploit. So in this slide we summarize some of our key contributions. So first we propose a semi-automated approach to classify vulnerability related GitHub pages, and for that we use NVD as our ground truth. We also apply two simple and interpretable algorithms, namely FP growth and decision trees, and these algorithms are used to extract patterns from the data. And finally we reduce manual labeling efforts and also provide additional artifacts that could be used to assist in the task of vulnerability risk assessment. Now we give an overview of our pipeline. So the first steps of this pipeline consists in collecting data from NVD and GitHub. So from NVD we extract only hyperlinks pointing up to GitHub. We also extract their tags. And in our analysis we observed that NVD tags are accurate but are also incomplete. So this represents an opportunity for us to predict tags for hyperlinks without any tags. And next we extract the context from GitHub pages associated with the hyperlinks, and from these contents we extract 75 features. These features can be grouped into four categories, and these categories are keywords, URL type, URL file extensions, and also a variable indicating whether there is a screenshot or not in the GitHub page. Another step in our pipeline is to map the original hyperlinks into one of these 5 tags, which includes the tags that we are interested in, so namely patch and exploit. And in NVD there are 13 different tags, and details about how this mapping works can be found in this table. Now that we already have both features and ground truth, we can train the models, for instance a decision tree, and these models can be used to classify untagged hyperlinks as either patch or exploit. And this is our pipeline. So let's focus now on the experiments. We first discuss the experiments using decision trees, and in this experiment we split the data set into two disjoint sets, one for train and the other for test purposes, and we tune the hyperparameters on the train set, and the test set is used to evaluate the model. And in our approach we learn one tree for each class. You can see here on the right side of the slide an example for the class patch, and we can extract a number of insights from this tree. For instance, we learned that the most important feature to detect the presence of patches on GitHub pages is the URL type. So commits and pull requests typically are evidence of patches instead of exploits. And also we notice the presence of keywords, and so keywords can also be relevant to predict exploits and patches on GitHub pages. And you can see here here also the screenshot. So typically screenshots represents evidence of exploits instead of patches. So the next experiment uses ChatGPT. Roughly speaking, we provide it with the GitHub content and ask it to assign the label patch or the label exploit. And we evaluate the results on a sample of 100 GitHub pages. In particular, we compare ChatGPT classifications against our manual labeling, and we verified a high agreement ratio. And so among the insights we can extract from these experiments, we observed that ChatGPT focuses on code snippets and step-by-step instructions when detecting exploits. In contrast, when detecting patches, ChatGPT seems to focus on the presence of update instructions and user activities such as issues closure and comments referring to a fix. And in summary, in this presentation, we investigated and automatically classified vulnerability-related GitHub pages as patch or exploit. And for that purpose, we used NVD, noting that it is a good source of information for that specific task. We also leverage role mining and decision trees, showing that they are instrumental for that purpose. And in both cases, we achieved a high level of accuracy in identifying patches and exploits. We also showed that ChatGPT is effective to label GitHub pages as a patch or exploit. And also, it is useful to provide additional insights. And as feature work, we intend to analyze GitHub pages that are not referenced by NVD. We also intend to design an automatic classification of exploit maturity and also to provide investigate better prompts for ChatGPT. So that's all. Thanks everyone.